Hello everyone, I'm Jane Mahilom. This is 2A, and today I'm going to teach you about minimization of dfa. In this lecture, we were trying to understand practically about minimization of dfa. So here we have an example of dfa in which I have 5 states: A, B, C, D, and E. So our task is to minimize this dfa. So first we need to draw the transition table for this dfa. So here I have drawn the state transition table for this dfa. As you can see, A, the zero inputs of A goes to B. So here it is. And A, one input goes to C. And B, zero input goes to herself, B. So the input 1 goes to D. So in C, the input 0 goes to B, and the input 1 goes to itself, C. So in D, the input 0 goes to B, and input 1 goes to E. And E, input 0 goes to B, and input 1 goes to C. We have to perform the minimization of this dfa. So in order to do that, how we have to start? We need to write the zero equivalence, then we'll go to one equivalence, two equivalence, and so on. So the first step to write down zero equivalence, write the non-final state together as one set. So here it is, zero equivalence. So we need to write the non-final state in this dfa. So we have A, B, C, and D. And you have to write also the final state as another set. So we have one final state, E. So we need mm. So here we have the non-final set, A, B, C, and D. And my final state is E. It's very simple to write the zero equivalence. You just need to write the non-final state in one set and final state as another set. So here we're going to write the one equivalence. Now we're going to write this one equivalence in writing one equivalence. You have to look at this row of in one set now. So one equivalence. So you need to see the first you need to see the A and B. So in order to first we need to check for EB. Here we'll continue. So how would we do that? We need to check for EB and check at the transition table where the E and B and getting input 0 and 1. So here it is. So A, the 0 input of A goes to B, and in B, the 0 input goes to B. So okay, okay. So here are my non-final set, E, B, C, and D. And my final state is E. It's very simple to write the zero equivalence. You just need to write the non-final state in one set like this. And the final state as another set. So here we're going to write the one equivalence. Now we're going to write this one equivalence. In writing one equivalence, you have to work at this row in zero equivalence this. And in order to check if this state are one equivalent to each other, so first we need to check for EB. here we'll continue. So how would we do that? You need to check for EB. You have to check in the transition table, this EB. So on getting input 0 and 1. So in order to get the 1 equivalence, you need to check the EB here, EB. So you have to check the 0 input and 1 input in EB. So in EB, the 0 input in EB goes to B. And B, the 0 input of B goes to B. So it is okay. So in one input in A, it is goes to C. And the 0 input of B goes to D. So in order to know the 1 equivalence, you have to check the 0 and 1 if D goes to or D goes in one set. Like the 0 input of A is B, so okay. And the 0 input of B is goes to B, so they're one set, they okay. So in one input, the A in A, the one input goes to C. So it is in C, this. So in B, the one input goes to D. So okay, they're in one set. So this is okay. The A and B is checked. So, okay. So we had to write down the E and B. So second, you have to check also the A, C. So in A, the 0 input of A goes to B. So okay. The 0 input of C goes to B. So it is okay. So in 1, the 1 input in A goes to C. And in C, the 1 input goes to C. They're okay. So A and C, check. So you have to bring down the C. So third, you have to check also the E and D. A and D. So in A, the 0 input of A is B. So, okay. And in D, the 0 input of D is B. So it is okay. In 1, the 1 input of A is goes to C. So it is okay. And the 1 input of D goes to E. So D is wrong because E is in another set. So you have to make another set for D. You have to close this and this. So this set E, this is in another set. So you have to bring on na lang the E. Okay, so here we're going to discuss about the second equivalence. So in order to find the second equivalence, you have to check in the first equivalence. So we have to check the E and B. So the 0 input of A goes to B. They're in one set. And B and the 0 inputs of B goes to B. They're in one set. Okay. And so we have in one input, the one input in A goes to C. They're in one set. With the one input of B goes to D. So they are wrong. The E and B in this set is wrong. It's because the D is in another set. So you have to bring down the A here and you have to add another set on B. So you have to check the E and C also. So E and C, you have to check in the transition table. So the zero equivalent of A goes to B, and the zero equivalence of C goes to B. So it is okay because they're in one set. So in one input, the one input of A goes to C. Okay. So the one input of C goes to C. So check, they're in one set. The E and C are in one set in one equivalence. So you have to bring down the C. So you have to close these, and in D and E, you have to bring them because they're the only one. You have to bring down the D and E. So we have to write the third equivalence. So in order to get the third equivalence, you have to check also in second equivalence. So just like this, you have to check for E and C. The E, the zero input of A, it goes to B. The zero input of C goes to B. So check. Then one set. So the one input of A goes to C, and the one input of C goes to C. So they are okay. They are so in order to get the three equivalence, I have to write only for E and C. E and C getting input 0. E and C getting input 0, it goes to B, and input 1, E and C also goes to C, where so again we get the same status, so they are 3 equivalent to each other, so we need to write E and C in one set. And for B, D, and E, because there are 3 separate sets, and I cannot combine them with anything, so I have to bring down this 3. So we need to draw the Dfa with this set. So we have to combine the E and C. B, E, and D. So in EC, in state transition table, E and C, the zero input of E and C goes to B. And the one input of E and C goes to C. So we need to write 1 itself in EEC. In B, the zero input of B goes to itself B, 0. And the one input of B goes to D. And D, the zero input of D goes to B. And D, the one input of D goes to E. And E, the zero input of E goes to B. And the one input of E goes to C. So